Hello. Today we're going to start learning how to factor, which is our next major topic in our work in Algebra 1. We have been working with polynomials when we've learned how to add, subtract, and multiply. And so now we're going to work backwards from that. That's what factoring is. We're going to go work backwards from multiplying and try to find what the original answer is. So these are notes 5. If you can record this in your notebook, that would be great. Again, some background is we have been distributing. So giving the number on the outside to each term on the inside, this would become 3x squared plus 9x plus 18. If you're having trouble doing the distributive property still, please let me know. And then I can help you with that, because we should have mastered that already. But now we're going to factor. So we're going to go backwards. We're going to have this answer, and we're going to practice today rewriting it as the product of two things: the greatest common factor, 3, and the leftovers. So I have kind of 3 general steps that I use when I factor out the greatest common factor. The first is that I have to find the greatest common factor. That's what GCF stands for. It's the greatest, I spelled it wrong, common factor. That's the biggest number that fits into all of the terms. After you find what the greatest common factor is, I want you to write the greatest common factor outside of the parentheses. So in this case, if I'm looking at 6 and 9 and 18, if I know that the greatest common factor is 3, I would write 3 outside of the parentheses. And then the last step is to divide. If you remember the distributive property, you multiply, and so we're working backwards here. And so we're going to divide away the greatest common factor. So 6 divided by 3 is 2, and then the variable stays. 9 divided by 3 is 3, and 18 divided by 3 is 6. And so this is my factored answer, which, if you look, was the original problem. So we're going to find the greatest common factor. We're just going to write that number outside of the parentheses, and then we're going to divide. Now, the hard part about this is making sure you can find the greatest common factor. So if you're somebody that struggles with multiplication facts and division, this might be particularly challenging for you, because this relies on the knowledge of your multiplication facts. And so how do you find the greatest common factor? I want you to do prime factorization or factor trees. If you can't think of what the greatest common factor is. So if I want to find the greatest common factor with 48 and 30, for example, you might be able to brainstorm. You might know right away the answer is 6. But if you don't, this is your backup plan. Factor trees are your backup plan. You are going to split up the number into into 2 factors. So factors multiply. So you would think, what 2 numbers multiply to be 48? And the first 2 that I thought of are 6 and 8, because 6 times 8 is 48. And I keep splitting these up until they're prime. That's what the prime part is. Remember, a prime number is any number that has no other factors, so besides 1 in itself. So some prime numbers would be 1, 2, 3, 5, 7, not 8, not 9, not 11, 13, not 14 or 15 or 16. 17 is prime, 19 is prime, 23 is prime. These are all prime numbers. They keep going, but those are all the first couple prime numbers. But 6 and 8 are not prime, so we would need to break both of those down. 6 breaks down into 2 and 3, and I'm going to circle those because those are my prime numbers. And then 8 breaks down into 4 and 2. 2 is prime, 4 is not, so I have to break down 4. 4, I ran out of room, breaks down into, needed some paper. 4 breaks down into 2 and 2. So 48 has a lot of prime factors. Let's do 30. 30 is 3 and 10. Maybe you thought of 5 and 6. That would work too. It doesn't matter how you split them up, as long as they multiply to be the